Hi. So, we will be continuing our discussion on cloud computing. Today, we will be discussing on another major aspect of this cloud computing, which is which we can say cloud security. So, we will talk, we will try to have a brief overview of the security per se and how this security affects cloud computing. As we all understand that when we go for cloud computing, whether it is a infrastructure as a service, a platform as a service or software as a service or anything as a service, what we are relying on a third party service provider. So, our application, data, processes are running on some third party. So, whenever it is running on third party, the security becomes the issue, especially that what is the availability, where my data is stored, whether it is being seen or intercepted by my some other parties, and those concerns will be there. And especially if this is a mission critical operations or mission critical data or some critical data like banking data, defense data, even academic data related to students results and other things, this needs to be looked into in a various serious fashion. We will see in the course of the things that one of the major hindrance towards going towards this cloud is more than technology, rather more this concern about security, what will be the policies, what data policy, etc., and so forth. So, with this we will start our thing, but before going to that I thought that it will be quick brush up of what do you mean by security in terms of when we talk about computer security or information security or network security. So, what are the different aspects are there? It is likely that all those aspects in some form or other will be also reflected in the cloud, but the concern may be different. So, before going to the cloud security per se, we will see security in general for any computing service, computing and networking service. Okay. So, if we look at security, what are the three basic components? One is the confidentiality, integrity and availability, right. This is what we say CIA components, right. Confidentiality deals with keeping the data and resources hidden, that you do not know that where the data is, that it is confidential. Integrity is that data integrity is maintained, like or origin or the source integrity is maintained, right, like so that whatever I send from A to B receives the same thing, or that integrity or authentication of the source that I am getting from the A itself, it is there. And availability, enabling access to the data and resources, that is another important component, right. So, that is what we see, that most of the attacks are going as denial of services where the availability is compromised. So, the everything is fine, but finally, you do not have the resource at your hand. So, it is some sort of a DOS or sometimes the DDoS type of attacks. So, any security attack on the other say that any action that compromises the security of the information or any action which violates the CIA type of things, that is basic premise, right. There are a lot of other components we will see. So, if we look at, there are immediately it will come up that there are typically 4 type of things may be there. One is interruption, one is interception, modification, fabrication. So, this 4 components more or less encompasses, or combination of this more or less, or it encompasses all type of things which are compromised during a attack. So, our basic model is a source sending a data to a destination, and when we talk about interruption. So, that the message or the communication path is interrupted. It can be interception, that the goes from source to destination, but somebody else also intercept and listening to the thing. So, this is attack on availability, this availability is blocked. This is attack on confidentiality, like you are sending from A to B or S to D, and somebody else, that intruder I is listening to that. It can be attack on modification, that this attack on integrity of that data, right. So, or even the origin, right. Source A is sending to D, but in between there is a intruder I which intercepts the message, changes the message and send it to D. So, for D it is a message coming from S, and the message aim has been changed to message aim dashed, but still for D it is the message which has been sent or which has been forwarded by sources. So, that is a attack on integrity. So, there can be attack on authenticity, right. I pretend, or intruder pretend to be the sources, right. So, it is attack on authenticity. So, I need to authenticate who is my source. So, before receiving a message, I need to know that I am supposed to receive from a authenticated source S, and I am receiving those messages. So, there is a attack on authenticity, or what we say fabrication. Now, so one side we see that the major security components, other side that the type of attacks which can be there. And if you look at this is true for whether it is a computer security or a information security or network security or cloud security, right. It may have different type of characteristics and manifestation, nevertheless it has the same type of what we say same type of problems or same type of security issues it arises. Now, if you look at that, what are the threats, right. So, threats does not mean it is attacked, right. So, like vulnerability does not mean that it is compromised, but these are the possible threats. So, classes of threats, one is a threat of disclosure, right. So, I have a threat of disclosure, like which is type of in the attack what we say snooping. So, a threat of deception like modification, spoofing, repudiation of origin, denial of receipt and type of things. So, this is a threat of deception. So, there can be a threat of disruption, that is if it is a modified, then the threat of disruption of service, and another is a threat of usurpation, that is modification, spoofing, delay, denial of services. So, these are different category of threats which are there. So, we have attacks which have security concerns and threats, these are different components. Overall, whenever a IT systems or any information system, whether it is organizational or it is personal or it is inter-organization, intra-organization, whatever, they are guided by policies and mechanisms, very tricky issues. So, policies says what is not allowed, right. So, the policy says that what is allowed, what is not allowed, right. So, it tries to do it in a fashion that which of the things can be allowed and things. There can be hierarchical way of defining policies, there can be different way of things, we are not going to that. So, this defines the security of the site systems, overall information structure, overall network access protocol, and individual to group to distributed anything, right. So, there is a policies. Usually in organizations, policies are made somewhat centralized in the sense it has been formulated across the for all components of the organizations, and it is something a sort of a policy making body does it. Now, incidentally the implementation is most of the time distributed, like I say that I have this IIT Kharagpur network. So, there are several departments, there are several sub networks, there are several layer 3 plus, layer 3 and layer 3 plus type of switches. So, it says the policy that this way the traffic will go and etc., and not only that, there additionally there are halls of residence etc. At the same time, this policy need to be implemented across this different category of devices. So, the implementation is often in a distributed fashion or in different devices and type of things where the. So, now there is a big challenge how to guarantee this implementation conform to the policy one to one, right. It is nothing more or less what the policy defines. So, there is these are some open not exactly open problem, these are very strong research problem across the world that how to formally say that your implementation and policy match with each other and so forth. Now, so policies says what is and what is not allowed, whereas on the other hand mechanisms enforce policies, right. So, I have mechanism to enforce policies. So, composition of policies, if the policy is conflict, discrepancies may create security vulnerability. So, there is another thing. If it is if when we compose policies, so if I have several policies and composition of the policies, if there are conflicts, discrepancies may arise, and then there can be security vulnerabilities. Like I can say that one policy says that this traffic can be allowed, or another policy said that this category of traffic should be denied, and you see there is a overlap that which can be either allowed or denied, you need to decide, right. This mainly happens because number of cases this implementation in a distributed way, and if sometimes there are clash in the local versus global policies, etc. So, this need to be addressed, this need to be first of all identified, and this need to be addressed, and this becomes a very critical thing when there is an organization is pretty large to look at individual policies and verify and all those things. So, looking all those things, so what we have seen, there are security models or security objectives, there are attack models, there are threats, and there are policies and mechanisms. So, these are different components which looks at different way of the things, right. Now, I need to bring them together and have what is my security goal. So, one of the major security goal is prevention, prevent attackers from violating security policies. So, that should be there. So, attacker, if I have the security policies, if it is restricts that thing, attackers should not be able to violate the security policies. Detection, detect attacker violation of the security policy. So, detection, that when the security policies are being violated by the attackers, need to be detected, right. So, detection can have then we will try to, the earlier the detection is, more strong your security perimeter, right. So, we need to detect as early as possible, because if the attack has gone into the place, then what we are left with is more of the postmortem of the what had happened, and basically learn to look at the other things. There are issues of another issue is recovery. If attacked and if compromised, if down to some extent or fully or partially, then how to recover from this thing, right. So, what will be my recovery mechanism from this type of things, like stop attack, assess and repair damage, continue to function correctly even if the attack succeeds, and there are different type of things people that there are in best practices. We have in critical system as redundant systems, there are logging mechanisms to recover and other things. Nevertheless, we need to recover from the thing to a stage where we were like pre-attack stage type of things. On all doing so, we incurred cost, right. All this comes with a cost. Trust and assumptions, that is another aspects. So, underlie all aspects of security, right. So, I have some trust and assumption, I trust this system, I assume that system will work fine, or this particular application and so on and so forth things are there. So, it all trust, and if you look at our day to day life also, for security mechanisms, we have some sort of a trust and assumptions, like I say, I understand what we trust, that the security person who is guarding that particular installation or particular premise can be trusted, right. So, I assume that this can be trusted to this extent and so on and so forth and type of things. So, this also is important thing. So, policies unambiguously partition system states, right. So, that is if you look at the system state, system goes on different state, because first of all it is a dynamic thing, right. It is not that it is statically one defined things are there. So, it should unambiguously partition the system state, that means I am in this state or this state, which state I am there. So, it should be partition, correctly capture the security requirement of every stage, right. So, it will not only partition, it should also security requirements of every stage. Mechanisms assume to enforce policies. So, mechanisms are there to enforce policies, support mechanisms work correctly. So, that the mechanism is basically a implementation or realization of the policies, and that should be there in place. Now, if we look at a little bit holistically, so if I have like set of reachable states of a system, right. So, if the set of reachable state is in this this type of mesh, and if I have a set of secured states like this type of hash line, right. So, one we say that if the set of reachable state is within the overall set of secured state, then I say it is fully secured, right. So, what I am trying to say that the system goes over different states, all are within the security state. So, I have say I have security state at S1 to S20 as secured. My system basically hover between S5 to S16. So, that means it is always in the security state. It can be precise that the it totally matches with this the set of security and set of reachability is matches. Other can be broad, that means all are not in the security zone or in the secured state, but there are some state which is there, right. The one thing we should know that how my security policy mechanisms vis-a-vis work. So, that I can say that how much secured I am. So, that is a issue of assurance like which consists of specifications, right, like requirement analysis, statement of desired functionalities, design how the system will meet the specification, and implementation program systems that carry out design, right. So, what it tries to do that in order to have properly design the thing, I can assure that this much security has been can be assured based on my my design specification, etc., right. So, these are the best practices which need to be put into place, so that my security level goes up. Now, there are issues of operational issues, or sometimes there are economical issues, right. Cost benefit analysis, is it typical, it is cheaper to prevent or recover, right. So, so whether which is costly, like it is recovering is costly or things like I say that I have a lab which has some Linux installation or Windows installation or combined of them, and we run the lab on day to day basis, but as such we do not store anything in the system, right. So, in that case that is students are supposed to bring their documents or download their codes, etc., run and then release the thing, right. But end of the day there is no question of storing any data, or there is no responsibility from the authority, so that the data will be saved, etc. For that I may not look for much interested for preventing the attack, right. Even some attack is there, if I can recognize, I can always reinstall that. I can have already a image of the whole system, and I can reinstall the image, right. But on the other hand, if there is a data intensive or say research data, etc., then I am more interested in preventing the attack, right, or a system which is online running on things, I want to prevent the data. So, that is cost analysis benefit. Other is the risk analysis, right. Should we protect something, how much should we protect this thing, right, how much risk is there, there are laws and customs, right, that are desired security measures illegal, will people do them, etc. So, we have different operational issues which are there. There are of course, some of the human issues, right, organizational problems or people problems. So, there are always human in the loop, and there are human issues of responsibility versus authority and so on and so forth. So, if we tie them together, so threats are there, policies are based on the threats, policies are made, based on the specification, based on the things policy specification, the design is there, based on design, that implementation, and then operation. These operational issues are fed back either to the implementation or design, specification and things, or operational issues comes as a threat. So, this is if we try to make them together, bring them together, it is like sort of things. Now, what we are looking at as of now is more from the point of view of like from the providers or the from the system point of view, like what could be the possible threats, what could be possible policies, how to implement, what is the mechanisms, and so on and so forth, right. But if we try to look at that what are the different type of attacks, like one is passive attack, right, often information that is being transmitted eavesdropping. So, it is not the attacks, but these are more eavesdropping. So, two types, release of message content, it may be desirable to prevent the opponent from learning the contents of the transmission. So, release of the message content may be one of the attack. Traffic analysis, like I do not look at the message per se, but I want to look at the traffic, right. If the traffic is highly volatile or heavy or low, I try to predict that what could be the effect of the type of mechanisms going on, right. I can say that if there is a very high traffic, that may be some sort of a video conferencing or video chat is going on, and it may be something need to be looked at to me something. If it is a low traffic or medium traffic, I can say that this is the type of things, and based on not only the traffic versus time etcetera also plays different important role. Usually passive attackers are difficult to detect because they do not do direct harm and are very difficult to detect. Whereas, on the other hand we have active attackers, like involve some modification of the data stream or creation of false streams. So, that is these are all active attackers, right. So, four categories. So, one is masquerade, one entity pretends to be different entity. So, that is the one attacker. Replay, passive capture of the data unit and its subsequent retransmission to produce unauthorized effect, right. So, this is a replay attack, right. So, content passive capture of the data units and its subsequent retransmission, huge amount of retransmission of the data. Modification, some portion of the legitimate message is altered. So, that is the attack of modification. Denial of service, prevents the normal use of communication facilities. So, this is a DOS type of attack or denial of services attack. So, all these attacks actually create problem in our in the operation of the active system. Now, the security services, as those things we have seen that these are the security threats and things, security services try to provide these sort of services, right, like confidentiality, authenticity, integrity, non repudiation, access control, accessibility, right, availability. So, this first thing we have discussed, non repudiation, what we say the order is final, right. It is like that you say you order something, like you say that the bank, you instruct your bank that you transfer over online, that you transfer x amount from my account to somebody else's account, and next day I go to the bank that I never gave this, right. So, there should be a way of handling this. So, this non repudiation is such thing. So, it basically says the order is final. Access control is a big field, that how this access control will be there. There are works on role based access control mechanisms and so on and so forth. It is basically say that prevent misuse of resources. So, you should have that particular resource, particular access to a particular resource center, so that you can use that resources. Availability, performance and non eraser type of services. So, that is denial of services service attack, and there can be virus that deletes files. So, that is also a case of non availability. So, role of security. So, if when you talk about computer security, network security, information security, cloud security and so on and so forth, what are the role of thing? The security infrastructure should provide first of all confidentiality, right. That means protect against loss of privacy. The integrity, protection against data altered data alteration or corruption. So, that is the protection of this the integrity, because as you have seen integrity that during the message transfer the data is being altered. Availability, protection against denial of service, authentication, identification of legitimate users. So, that how to identify and authenticate a legitimate user. Authorization is a determination of whether or not operation is allowed by a certain user. Non repudiation, as we have discussed, the order is final. Safety, protection against tampering, damage, theft, etc. Right. And we have a series of attacks based on the different type of vulnerabilities and so on and so forth, from social engineering to phishing, password attacks, buffer overflow, command injection, and etc. etc. So, these are different type of attacks which are there in the information system, which are true in some sense for the cloud infrastructure also. Now, if we look at a typical scenario like say network security, which is very prominent because the cloud is based on a is basically built on the distributed systems which are leverage on network, and so it is important that the basic network level security is high. So, network security works like this: determination of the network security policies, that what should be the security policy, implementing those policy, then reconnaissance, so that should to see that whether the security things are in place or not, vulnerability scanning, like how vulnerable I am, so that look at the vulnerability scanning. There is a concept of penetration testing, that means, or what we say self attacking sort of scenario, self and safe attacking scenario, that how much I can penetrate to the system. So, it is a penetration testing, and there is a need of post attack investigation. If there is a attack, then post attack investigation. So, determination of security policy, that the security policy is a full security roadmap, and for any organization smaller things, if it is a inter organization, so that the what will be the security policies need to be placed, right. It is a full roadmap to be there. The network design should reflect these policies. So, if it is a network thing, so whenever you are designing, it should conform these security policies. So, implementing the security policies, implementing policies include installation and configuration of security measures like firewalls, installation of configuration of IDS, and there are several other type of things which need to be there. So, if we look at it is a big picture like this, where you have different, that is demilitarized zone, internal network, and that firewall or network address translator, NAT, switch, firewall, and type of things, right. So, it is dual homing, or two firewalls are there. So, implement security policies, either the policies or the access rules in the firewall or IDS, or there is a concept of honeypot or honey net, where vulnerable things are there. So, that lot of attacks will be there, and the security means security personals understand that what sort of attacks is there. Based on that signatures, they basically fine tune their IDAs or firewall policies. So, the next thing is that need to learn about the network, right. So, in order to whether to attack or prevent, you need to learn of the network. So, IP address of the host, identify key servers with critical data, and so on and so forth. So, there are two forms are there, one is passive, which is undetectable, one is active, it is often detected by the IDS, right. So, there are, this is a need. There is a vulnerability scanning, that as we are discussing couple of minutes back, that I need to basically scan my vulnerabilities, right. So, that how vulnerable I am in the system wise. So, there are different scanner, there are in case of a network, there are different scanner, like there is a open source thing, NESAS, Nmap, and so on and so forth. So, that you can basically scan that which are the ports open, what are the possible vulnerabilities and type of things, right. So, this is important that you scan and see that what is the security, quote unquote security health of your installation. So, other scanner will allow to exploit them, they are called Metasploit and type of things, which has a security database. There are different security vulnerability database, like one such is that NVD, National Vulnerability Database, which basically says that what are the different vulnerabilities. So, scanners are need to be updatable, so that it goes on as in case of our antivirus etc., which are primarily scanners. So, need to update with the signatures. And then we have the penetration testing, like one we do a vulnerability analysis of a say a network, and then looking at the vulnerabilities we do a penetration testing of the system, that how much I can penetrate into the systems and type of things. These are safe attacks, and let us means a organization or the security personnel can know that what are the different vulnerability points and put appropriate patches. And finally, we have a post attack investigation, the forensics of the attacks. The process is heavily guided by the laws that how this post attack or post mortem scenario is going there, then retain chain of evidences that how things happens etc. So, these are post mortem or post attack scenarios. Now, if you look at in case of a cloud, all these things also come in different, in same or different forms, right, because these are more generic, though we discussed at the end little bit of network related, but these are primarily more generic attacks. And then we have this post attack investigations to look at that what are the different attack pattern etc. And we will try to look at in our next lecture or so, that how what are the implications or what are the speciality of this security in case of cloud computing. Okay. So, we will stop here today. Thank you.